Hey Wheaton North, Mr. Yergler here. We're going to talk about balancing equations again, but this is kind of another layer to the problems. We're calling this advanced balancing. It's the same thing. It's just we're kind of adding nomenclature to it as well. Okay, because we're translating from words to the formulas and then balancing. All right, so let's get started. First, I want to talk about a few tips for success, just in general, whenever balancing. Remember that you can only change the coefficients. You can't change. That's the number in front of the compound formula, right? You can't change the subscripts. Do not change the subscripts, the little numbers in the formula, because that changes the compound, right? Like if you have H2O and you change it to H4O because you need more hydrogens, then that's a whole different compound, right? That's not water anymore. Go ahead and pause the video and make sure you get all this written down, okay? You want to write the formulas first. You have to have the right formulas or else the reaction will actually never be balanced. And you can add a blank in front of each formula so that you have enough space. Basically, just leave yourself enough space. Okay, and keep some sort of atom inventory. I've showed you how to do the particle picture method, where you just kind of like draw all the particles, as molecules. You can also use the table method, where you're kind of listing out the number of each thing on the reactant side and the product side. For some of the simpler ones, you might be able to keep that atom inventory in your head, but if you kind of get yourself tripped up, I would write it down so you make sure you get it right, and then always double check your work. Okay, it's really helpful to use a pencil because you often have to erase the coefficients as you work your way through the problem. All right, and this is a big tip. This is a really good tip. Whenever you see a polyatomic ion, so CO3 carbonate is a polyatomic ion in this case, and notice that it's still carbonate on the other side, right? So it's staying together as a group. You can balance that as a group, right? So right here we have 9 oxygens total, and you can balance it as individual oxygens, but we have 3 groups of carbonate, right? Because this little 3 here, and this 3 is part of the carbonate group, right? Because carbonate is CO3. So we have 3 CO3s, and we only have 1 CO3 over here, so we need a 3 coefficient right here, and that gives us the 3 carbonates. A lot of times, whenever you have polyatomic ions, it's pretty helpful to balance them kind of as a group, keep them together. It's also sometimes helpful to think of water as HOH. So notice that we have OH right here. This is boron hydroxide, and we have 3 OHs, right? That's a polyatomic ion as well. The OH is actually in here as well, but it's just kind of written differently. So if you rewrite that as HOH, it's still H2O. Then we're showing the polyatomic ion as a group, kind of like what we were doing up here, right? And then when you balance it, we have 3 OHs here, so we're going to need a 3 here, and then you end up changing it to 6 because of the oxygens. There are many ways to balance an equation. So I've shown you the table method, right? I've shown you the particle picture method. You don't have to start with any particular element or compound. If you want to start by balancing the borons, you can. If you want to start by balancing the sulfates, SO4, you can do that as well. It's always going to work out to the same regardless of where you start. So if you get stuck, if you feel like you're not figuring out, just erase all your coefficients and start with a different element or different compound. All right, one quick thing to remember: some elements are diatomic. They always have to be with something else. So hydrogen is a good example. Hydrogen can be with another nonmetal like chlorine. HCl is hydrochloric acid. It's the acid that's in your stomach. But if it's by itself, if it's pure hydrogen, then it's not by itself. It's not individual atoms. It's diatomic, meaning 2 atoms, meaning it's H2. So oxygen gas is O2, nitrogen gas is N2, fluorine is F2. There's 7 of these, and they make a 7 starting at the 7, so it's kind of easy to remember. So you make a 7 on the periodic table like this, and you also want to add hydrogen. I like to remember this by the name Hofbrinkel. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. So I think this is a really easy way to remember. Just remember that Hofbrinkel are the diatomic elements. Okay, we're going to have 2 practice problems. So, and this is the translating part, right? Where you have to translate from words into the formula. So potassium chlorate is strongly heated. It decomposes, so this is where the reaction is occurring, right? So we have 1 reactant, just potassium chlorate. And to yield, so that there's your arrow, that's where your arrow is going to go, oxygen gas and potassium chloride. Now I rewrote these on a piece of paper so I can show you how I'm balancing them. So let's take a look at that. So here I just rewrote the words alone. So potassium chlorate from the problem decomposes to yield oxygen. Whenever you see that yield, that's your arrow, right? So this is our reactant, and we have two products, oxygen and potassium chloride. Now, in order to balance this, we have to have the right formula. So we need to translate this from the words to the formula. Potassium has a +1 charge, and it's K. And chlorate, notice that ATE ending, that kind of tells me to look at my polyatomic ion list. Chlorate is ClO3, and it has a -1 charge. So we're only going to need, if you crisscross or if you think about balancing out the charges, we only need one of each, right? So this is KClO3. And I'm just going to do it right. I'm going to just keep going right underneath my words. Oxygen is diatomic. It's in that Hofbrinkel name. So when you see oxygen, it's not just O, it's O2 because it's diatomic. And then we have potassium chloride. So potassium is still the same, it's +1, and chloride, now we're dealing with just chlorine, right? And that's a -1 charge. So if you crisscross or if you balance the charges, that's KCl. Alright, so we need to keep track of how many of each thing we have on each side of the reaction. So on each side of the equation. So I'm going to list out my elements. So we have potassium, chlorine, and oxygen. And on the reactant side, we have one potassium and one potassium on the product side, and then one on each side for the chlorine. So those are balanced, but oxygen is not balanced, right? We have 3 here, and we only have 2 on this side. Okay. So we need to work on balancing oxygen. We have less on this side, so let's add another coefficient on this side. So I'm just going to add a 2, even though I can kind of tell that that's not going to quite get me to where I need to go, but we'll start with 2. And that changes this to a 4 on the product side, right? Because now we have 4 oxygens. So now we need more oxygen on the reactant side. So I'm going to have to add a 2 over here. And that changes, now we have 2 ClO3s, which means we have 6 oxygens total. And now I need to go back to the original oxygen on the product side because now I need more of those. So I'm going to change this to a 3. And again, if you're using a pencil, it's a lot neater because you can erase that coefficient. So I'm going to change this to a 6. However, that 2 that we added here, we need to go back and double check all of our other elements. Now we have 2 potassiums and we have 2 chlorines on the reactant side. So we're going to need more potassiums and chlorines over here. So I'm going to add a 2 on that side. And now we have 2 of each of those. So we have 2 potassiums, 2 chlorines, and 6 oxygen. So everything looks balanced when our coefficients are 2, 3, and 2. All right, let's take a look at the next one. Aqueous sodium hydroxide is added to sulfuric acid, and that formula is given because we haven't really talked about how to name acids. And then it tells us that the products are water and sodium sulfate. So I went ahead and wrote out the words so we can write all of our formulas. So sodium hydroxide, sodium is Na, hydroxide is on our polyatomic ion list, that's OH, and it's -1 and +1, so we only need 1 of each, so that's good. Sulfuric acid, the formula was given, that's H2SO4. And then it said the products are water, so I'm going to draw an arrow here because our products are water, that's H2O. And sodium sulfate. Sodium is Na, and it has a +1 charge, and sulfate is on our polyatomic ion list, that's SO4, and it has a -2 charge. So we're going to actually need 2 of the sodiums, or if you're crisscrossing, you can write a 2 there, and then the SO4, we only need 1 sulfate. So now we have our formulas written correctly. Double check yours, make sure yours are matching mine. All right, and then I'm going to go ahead and do my little table here. So I wrote out all the elements, sodium, oxygen, and hydrogen, but then I also am keeping SO4. This is a polyatomic ion, and it's the same on both sides. So I'm going to keep SO4 as a single unit. So I'm going to balance them as a group, kind of. We only have 1 SO4 as a whole unit. If you want to draw parentheses around this to kind of make it more obvious, then that might help you. And over here, we also have one sulfate. There's 1 sodium on the reactant side, 2 on the product side. And our hydrogens, we have 1, 2, 3, and 2 on this side. And then oxygen, 1 and 1. Okay, so let's take a look at something that we need to balance. It looks like sodium. Let's start with sodium. There's 2 over here, there's only 1 over here, so we're going to need to add a coefficient. Notice I'm adding a coefficient, I'm not adding a little subscript of 2 here, because this is the correct formula. Na2OH is not the correct formula for sodium hydroxide. So now we have 2 sodiums. We also increased our oxygens. We now have 2 oxygens, and we got to recount these. 2 hydrogens here, but there's also 2 here. So total on the reactant side, we actually have 4 hydrogens. Okay, so sodium is balanced. Let's look at oxygen. We have 2 oxygens on the reactant side. On the product side, we only have 1. So let's add a 2 here. And that changes our oxygen to 2. And it changes our hydrogen. Now we have 4 on the product side. And it comes out clean, where we have 2, everything kind of lines up perfectly on that last one, which is kind of what you should expect. So we have 2 sodiums, 2 oxygens, 4 hydrogens, and 1 sulfate, 1 group of sulfate on both sides. If you have any questions on any of these, then make sure you're writing those questions down right now in your notes so that you can bring those up in class tomorrow. This is Mr. Yergler signing off.